Our final video for this lesson is on the trig ratio of special angles. So our special angles are the 45, 45, 90, the 30, 60, 90. We're actually going to use these a lot. They are key to understanding the next things that are coming. So I'm going to use just a slightly different version. Instead of 1x, 1x, square root of 2x, I'm just going to go 1, 1, square root 2. And what I'm saying there is all 45, 45, 90 triangles have those proportions. So it might be 7, 7, 7 times the square root of 2, 23, 23, 23 times the square root of 2, but they all have those proportions. Since we're doing ratios here, if they all have those proportions, when I go to find my ratio, the 7s are going to cancel, the 23s are going to cancel, the ratios are going to come back down to this 1, 1 square root of 2. And then for our 30, 60, 90, I always start by finding my 30-degree angle. Across from that is 1, the hypotenuse is 2, and across from the 60 is the square root of 3. The square root of 3 is like 1.7 something. I'm going to use my calculator, give you an exact there. So the square root of 3 is 1.73205, so it's smaller than 2. So that is how I know the 2 is the hypotenuse and the square root of 3 is across from the 60. So across from the 30, which is your smallest angle, is your smallest side. Across from the 90, which is your biggest angle, is your biggest side. And across from the 60 is the middle one. So 1, 2, square root of 3. Again, the proportions might actually be 10, 20, 10 times the square root of 3. But when I'm doing the ratio, the comparison, that's what they're always going to come down to. So if I'm doing sine of 45, I'm going to use this angle here. Opposite over hypotenuse. And then rationalizing the denominator, I get square root 2 over 2. Remember what I'm doing there, square root 2 times square root 2 is the square root of 4, which is 2. So that's how that square roots are going away. So the sine of 45 degrees is square root 2 over 2. Cosine of 45, going to be the same, adjacent over hypotenuse. So 1 over the square root of 2, saving myself a little bit of writing, square root 2 over 2. And then tangent of 45 is going to be opposite, which is 1, over adjacent, which is 1. So 1. Now, for 30, make sure that you're using the correct reference angle. That's my 30. So for sine, that's 1 over 2. For cosine, that's square root 3 over 2. And for tangent, that's 1 over the square root of 3. Need to rationalize that denominator. And again, I probably should be more emphatic about where I'm getting these from, so let me just kind of review. Sine is opposite over hypotenuse. Sine is opposite over hypotenuse, so the 1/2. Opposite over hypotenuse. Cosine is adjacent over hypotenuse, square root 3 over 2. Tangent is opposite over adjacent, opposite over adjacent. Okay, sine of 60. So now notice I need to change my reference angle. So I'm no longer looking at the 30. I am now looking at the 60. What that means is my opposite and adjacent flip-flop. So my sine of 60 is the square root 3 over 2. Opposite over hypotenuse. Notice that it's equal to the cosine of 30, because all I did was use the same triangle but flip-flopped my reference angles. My cosine of 60, adjacent over hypotenuse. And then my tangent of 60, opposite over adjacent. So those are important, and those are going to end up getting memorized. They kind of need to get memorized. Not just kind of, they absolutely need to get memorized because we're going to use them. And for those of you thinking, well, can't I just do that in my calculator? Well, yeah, but hold on, let me show you what happens with that. Okay, I opened up my calculator here, my online. So if I do sine of 45, sine of 45, and I am in degrees, that's going to matter. See how I get 0.707? I don't want that. I want square root 2 over 2. They are the same. If I do square root 2 over 2, 0.707, they're the same, but I don't want it as a decimal. I want it as an irrational number. So that's why we can't be dependent on our calculator, and we're going to end up having to memorize these things. Okay, well, that is it for this video. And then we're going to move forward into some applications of our trig functions.